3.9 to 3.10 dividing fractions. I can divide fractions.
Thank you, Adefa. Are we all capable of dividing fractions?
Yes.
Now, there's a lot to dividing fractions. If we really want to make it into a lot, at this point, we're just making fractions a pretty simplistic thing. There's a saying that we need to remember. At the count of 3, I would like to do the saying together. On the count of 3, 1, 2, 3. When
Dividing fractions, multiply the second and multiply.
All right, so you said flip the second and multiply. We're going to get to that in a second, but what is another word for flip?
Inverse.
What's another word for flip?
Reciprocal.
What's another word for flip?
Kamal.
And this is us taking Kamal and flipping him upside down, right? Okay, so a reciprocal, an inverse, a flip, a Kamal, all would be taking something and turning it upside down. A complete 180. For those of you that watch the Olympics, the snowboarders, the skiers, the jumpers, when they have 180s, they flip themselves in the opposite direction. Yes, no? So for Kamal, we flipped him in the opposite direction. His head was up, we flipped, so his head was down, right? So when we divide fractions, moving down here to number 2, we actually take the second fraction and we flip it upside down. And then instead of dividing, we turn it into a wonderful job. So here was our original problem, 2/3 divided by 1/2. We rewrote the problem as 2/3. Instead of dividing by 1/2, we took 1/2 and we flipped it. And when you flip 1/2, it becomes
2/1.
And then the division sign became a
Multiplication sign.
So are we ever multiply our dividing fractions? No. If you do that flip, it gives you the right to go ahead and multiply. Okay? I know we don't understand why quite yet, but I just want us to understand the whole process first. So if I slide down here to number 3, here's our first problem. 3/4 divided by 2/3. Again, on the count of 3, can you tell me the saying when you have a division problem and there's fractions involved? On the count of 3, 1, 2, 3.
When dividing fractions, multiply, flip the second and multiply.
Okay, good. So do we have a division problem with fractions?
Yes.
So the first part, when dividing fractions, does that apply?
Yeah.
All right, we're dividing fractions. My oh my, that just connects the two parts together. Flip the second. So the second means the second fraction right here. So if I flip 2/3, it becomes what?
3/2.
3/2. Did we change it to 3/2?
Yes.
And did we change the division to multiplication?
Yes.
So flip the second and
Multiply.
do we do anything to the first fraction?
No.
No. Is multiplying fractions much easier than adding or subtracting?
Yes.
Why?
Because you don't have to find a common multiple for your number.
You don't have to find a common multiple for your denominator. Thank you, whatever your name is, Ayana. All right, so then we multiply 3/3. We got 9. 4/2. We got 8. Is this a proper answer?
No.
We needed to change it into a mixed number, right?
Yes.
And then this is the process. It's just a division problem. Number 5. I love that almost all of you in all 3 groups did this. When you rewrote 6 divided by 1/2, we're dividing fractions again. Almost all of you wrote 6 as 6/1. That's awesome. We talked about doing that. And then we took our second fraction and we flipped it and it became,
2/1.
and our division sign became.
Multiplication sign.
So again, we can flip, we can invert, we can find the reciprocal, or we can Kamal it. Say Kamal it.
Come on.
Kamal it, I appreciate that. It's going to be so good. I bet you when you're a senior, you're going to remember, I remember in 6th grade when we used Kamal as our example for inverting fractions when we're dividing. I bet you someone will, or if not some, if not one person, many of you remember that we used Kamal to do that. I will, Kamal. I'll never forget you.